Good morning, friends. Today I am teaching about again IT management. One of our chapter is operating system. What is operating system, and what is the use of operating system in our computer system? See, operating system is nothing but a system software. It's kind of software. What we have learned, what we know, it's a software, and it is called a system software. And just like in different operating system is using in all the devices, each and every devices where computer has been used, just like our laptop, our desktop, our mobile, our games where the computer has been used, and some anywhere where the computer has been used. And some examples of the operating system, one famous example is a Windows. Windows is nothing but an operating system. It's by Microsoft. Then we have Linux then we have Android, then we have Google Chrome OS. These are some of the example of the operating system. Then I can say that there is a type of operating system, just like single task operating system, then multitask, real time, and memory management. These all come under the operating system. So let's start with the operating system. I can say that operating system is nothing but a heart of your computer system. It's a heart. If operating system is damaged, so your entire your system is going to down. It will crash out. So every time when we are going to format our system, mainly what we are doing, we are formatting the operating system. We are again, when we want to format our system, then we put the Windows CD or Linux CD, whatever the operating system has been used by that particular PC, and we start booting with the help of that. So let's start with the operating system. What is OS? OS is nothing but is the operating system. What is operating system? Operating system is a software. What I have told you, it's a system software which makes a computer to actually work. Because I have told you it's the heart of the computer. So heart basically actually provides all the elements to run the computer system. So it's actually provide all the elements to run your computer system. It's a software that enables all program we use. It's enabling all the program whatever we are using, either Word, either Microsoft programs or anything. The operating system organize and control the hardware. Basically, it's a layer between hardware and your software, just like CPU and other. So it come between over there. So it's it also controls your hardware. Operating system acts as an interface between the application program and machine hardware. Application program is nothing but your just like your Microsoft Word, Microsoft Excel. What we are doing, these all come under the application program, and operating system is only the system software. I can say that. Some examples what I have told you, it's a Windows, Linux, Unix, Mac OS, which is Macintosh. Then what is again? An OS is a program that acts as an intermediary between use of the computer and the hardware, which I have told you. Major cost of the general purpose computing is software. So OS simplifies and manages the complexity of running application program efficiently. What happens? See, whatever the program we are running in the system, so operating system basically manage that program to run into the system. So whatever the program we are using, either we are using any Microsoft rated or some other program, whatever. So basically operating system provide a support to run that application program in the system. So system software basically supports to run the application software into your system. It's a simple definition. Then what is the goals? What is the aim or goal of the operating system? Why we are using? What is the use of operating system? In the 50s or 40s, 50s or 60s, when the operating system has been initially started. So I have told you there is a multi kind of operating, a single task, single user, So initially there is a single user operating system in 40s or 60s. So only one person at a time can use that particular system. So what is the goal of operating system? We are going to talk you about. It's about simply the execution of a user program and make solving user problem easier. It's basically whatever the program we are writing or we are doing. Just like if I'm going to open simple this, I have opened the simple PowerPoint. Because of our operating system this is running. If the operating system is not there, I'm not able to open even the PowerPoint presentation in front of all. So this is basically it executes each and every user program, and it is try to solve each and every problem. Use computer hardware efficiently. All sharing of hardware and software. See, it's basically it is doing lot of tasks just like memory allocation and all the things. So all the hardware related work it is doing properly. Just like example, allow sharing of hardware and software resources. Whatever the resources is, so it's thinking that this resource is applicable for this, so it is putting over there. Like that, it's manage each and everything. It's a kind of manager. Operating system is nothing but a manager of your computer system. It manage each and everything. Make allocation software portable and versatile. See, application software, what I have told you about. Make application software portable and versatile, so it can be used again and again. Provide isolation, security, protection among user programs. See, security is very much important while we are doing anything. Yesterday we have talked about the security, and day before yesterday, and yesterday we have talk about the IT Act 2000. So this why we are doing this, because of security reasons. So operating system is also provide a security kind of thing to your system. So no one can do some kind of illegal activities or hacking or something, because it's kind of protection provide you to your system. Improve overall system reliability. Yeah, if there is a good operating system, it obviously improve your system reliability and all. Error confinement, fault tolerance, and configuration, these all come. See, why should I study operating system? This is why the need of to use the study of the operating system. So first of all, need to understand interaction between the hardware and application. So why the use? What is the use of application software? What is the use of application software? What we are doing? What is the use of application software? Why it is required? Why we required? What is the use of hardware? So with the help of that operating system, we can learn these things. So new application or new hardware, inherent aspect of society today. Daily new I can say that operating system has been introduced. So to know each and every operating system, what is suitable for you, you can utilize like that. Need to understand the basic principle in the design of a computer system. So you can understand what exactly the designing of the computer system. There is a CPU, there is a memory, there is a virtual memory, there is a RAM, ROM. So each and everything we can be learned while we are learning the operating system. Efficient resource management, security and flexibility. Increase need of a specialized operating system. A specialized operating system, just like embedded operating system for devices just like cell phone, sensor controller. See, we are using actually in the cell we are using a embedded operating system just like Android and other. So this is also operating system basically which used to protect your cell phone from some I can say some malware or not. So this is software. This is again a kind of operating system which is called embedded operating system, just like your Android and other. We are using operating system, the sensor which is sense the I can say the climate or some other thing. Then controller, real-time operating system we are using in the aircraft, multimedia services, aircraft control, and this is something different. So abstract view of the system. What exactly the abstract view of this operating system we can see over there. See, there is a number of users, system and application program, and this system and application system software application software is nothing. System software is nothing but operating system. So operating system is a middleware between hardware, your hardware computer, or your application program. So just like what I have told you in initial slides, I'm showing with the help of one picture. So it is a middleware, it's a middle. So it's basically a layer, I can say the layer between your application and system program and your computer hardware. So it's between computer, there is a computer hardware, there is a application software program. So in between both of that, there is a operating system, and multiple users are using, you can see there is number of users are accessing these application and system programs. So all nowadays whatever the operating system is coming, so it's a kind of multi-user or multitasking. So you can see over here multi-user, so multiple user from n number of user can use this operating system at a time. It is very simple. Please keep in the mind, if the question asks you regarding the operating system, if you're going to see, my main motto is you to understand the things and make it with the help of picture or graph. My mind to say is with the help of some picture, so that the teacher who is going to check that paper, so he can understand that the student have understood those things which have been taught. So basically when you're writing in a theory paper, so basically you have to use, if possible, so you can use this kind of pictures, so that the teacher is also understand you have gone through my mental system thing and you have understand the things. And it is very easy to understand while the checking by the any teacher, so he understand the things, and he will, if he understand that yes, the student know each and every point very well, so he will give you a good marks. Because I think the most of the teacher, apart from the your theory, they are looking something, just some unique things, because everyone is writing a theory. In the theory they are writing a lot of things, but if you're writing something with the help of picture, so it will impact something different. And so you have to write in operating system, you have to write about the operating system, some of their goals, and you can abstract view of the system. If you make this picture, so it will give impact something different. So operating system views, so one of those is a resource allocated control program and kernel. So resource allocator, operating system is nothing but a resource allocator. It provides the resource to each and every software and hardware. So to allocate resources, software and hardware of the computer system and manage them efficiently. Only not it's providing the resource to the the software or hardware, but it is also manage. So that's why I'm asking that the operating system is a manager. I can say that manager of your computer system or your personal laptop or whatever. So it manage each and everything properly. See whatever if I'm going to give you the example of any manager, a people manager or a HR manager. So what they are doing, they are actually manage the resource properly. Workflow manager, so they are basically manage the people. That suppose this project, say there is in the company there is 10 projects are running on, and any project manager has come to the I can say workflow manager, any work manager. So he will ask to that HRM manager or workflow manager that I need this much of resources to this particular project. So what the HRM manager is doing, they are allocating some of the, they have a chunk of the people. So what they are doing, they are allocating that chunk, some of the people on that particular project. The same thing has been done by the operating system. So basically it manage and the resources properly at each and every I can say that each and everywhere where the requirement. Then it controls the program, control execution of the user program and operating of the IO device. IO is nothing but the input output devices. Input devices like your keyboard, your mouse, these are the input devices what I have taught you in the long back when we are running the basic of the computer. So output devices like your printer and your some scanner, these are the output devices. So these devices is also managed by the operating system. You understand? So input and output devices also control or executed by the operating system only. Then we have to learn about the kernel. Kernel, what is the kernel? The program that executes forever. Everything else in application with respect to the kernel. So kernel basically it is responsible for the execution of the program. The program that executes forever everything else in the application with respect to the kernel. So this is responsible for the execution. Then spectrum again, monitor and small kernel, special purpose and embedded system is real-time system. Embedded system I have told you about, which is in there in small devices just like your cell phone and all. And then real-time system, it's like your aeroplane and all, there is some real-time operating system have been used. Then batch and multi-programming. Batch in the sense there when the program is going in the batch form, the process is going in the batch form, and the multi-program is more than one programming at a time. Then time sharing in the sense a person, just like your server, mini computers and time frame workstation. In the workstation, they have divided the time to different tasks. So they are doing different tasks at a time. So it's a time have been shared with the different devices. Then your transaction system, personal computing system, which is nothing but your PC, mobile platform devices of all sizes. Mobile platform and devices, it's like any mobile which is using the operating system. See nowadays every mobile XYZ, any mobile you can take. If you're looking for BlackBerry using their own operating system, which is called BlackBerry operating system. If you're looking for I can say that Apple mobile, so they are using iOS, which is in iPhone, so they are using their own OS, which is called iOS. So most of the devices, I can say that if you're looking for any Samsung or some other phone, so they are using Android. And if you're looking for Nokia and Microsoft phone nowadays, because Nokia has been taken over by the Microsoft, so Microsoft using their own software with a system software or operating system, which is called the Windows. Next, what OS does? What the OS does? What is the problem? Why we are requiring OS? We have learned initially. We have gone through starting what is the operating system, number one. Then what is the goal of that operating system? Then why should we study operating system, that we have gone. Then operating system, abstract view of the operating system and views. What is the spectrum of operating system? Now, why does we require operating system? What operating system does? What it is doing? So, and an operating system performs basic tasks. It is not providing a very huge task. It is providing a basic task, just like controlling and allocating memory. See, basically, our system has basically to run or store the program. Where it is stored the program, obviously there is some memory where it is stored the program. When you are writing anything, if you are not going to save it, is stored in the temporary memory. And when you are again, that is calling that thing, so it will come from your temporary memory. So one is temporary memory, then we have a RAM, which is random access memory, then ROM, read-only memory, virtual memory. So these all are memory. So basically operating system controls that memory and allocate the memory according to the requirement. Then prioritize the system request. Prioritize the system request in the sense what the request has been sent first, it will go first. See, actually I can say that one second, I will show you, so might we understand better over here. Prioritize in the sense, don't go for spelling, I will show you. Just like I have initially, I will open one. I have opened text. So suppose in one I have opened one text file. Then secondly I have opened one word pad. Then I am opening calculator. So this is the prioritize. So what the computer, just like I have clicked in the, I have gone through here and I have opened the notepad. When I am opening the notepad text file, so first it informs the operating system that the user has asked to open the text file or word notepad. So it will open the notepad first. Then I have asked for secondly, I have asked for word open the word, so it will open the word second. Then I have asked third to open the calculator, so it will go over there. And again, when I have clicked to open the calculator, suppose I have clicked over here, so immediately it will inform these things to the computer, your operating system, to allow to open the calculator like that. Just like if I'm going to give you an example, just like our mind is also prioritize the time things properly. Just like initially when you open the system, suppose uh, you need to wear a attire. So first you start, just like if you start with shirt, then pant. So it is a proper way doing the things like that. The same way it is prioritize the work over there. Then controlling input output devices, what I have told you, input and output devices like your keyboard, your mouse, and output devices is like your what do you call? Output devices is like your scanner, printer. These are the output devices. Facilitating networking. Networking, yes, it is also facilitating the networking. It is also somewhere connected with the network also. Then managing the file system. It is also managing your file system, which is there in your system, computer system. Then structure of operating system. See, you can see there structure of an operating system. See, this is the application program and this is the system program. These two program over here, application program and system program, and the hardware. So I have told you in initial set, you can see over here, if you do remember. So application and program and system program, between these two there is an operating system. The same thing over attached. So application program and system program and the hardware. So in between these, this is a software. And apart from this out in the outer shell, I can say that the user is there. So user is allocated all around. This is the same. So application software is first, program with first, then system program, then the software comes, which is called the operating system. So the structure OS has 4 layers. Number one is the hardware. What exactly is the hardware? See, hardware. This is the hardware, layer 1. So hardware consists of your CPU, your main memory, and input-output devices. CPU is your machine, your main memory, which is RAM, and then your input-output devices. Nothing but your keyboard and your output devices like printer and all. Then software operating system. Second thing, after hardware there is a software, which is operating system. So software operating system is software includes process management, routines, memory management routine, IO control routine, and file management routine. So here you can see that software includes process management. It is process management rules. What exactly the process is required to run the system, what exactly the prioritized task view you need to going to provide these things, and memory management routine. So it will also manage the memory of your system. It will manage your RAM, it will manage your ROM, each and everything. It is also provide the segregation of your memory, where the data is required exactly there it is going to fit. Then IO control routines, input output control routines, file management routines. Then it will also manage your file, each and everything is done under the operating system. Then system programs. Then you can see over there, the third layer is of the system program. System program consists of your compiler, assembler, and linker. I have told you a long back about the compiler. What exactly the compiler will do? Compiler basically it's a kind of a program, a software which basically convert your written work into the code, and it will take the data at a time. And there is another entrepreneur which is taking the data line by line, but compiler will take entire program at a time and it will convert to your requirement. Then application program, just like this is dependent on the user need, just like a railway reservation system, bank database management system, or some other anything. So application program is, so how the system is start. So in the application program first, in the application program, just like my bank database system is there. So bank database system directly interact with your system program. System program is nothing but your compiler, interpreter, and this is related to your operating system and the hardware. So when I am going to write and I want to fetch some accounts from my bank database system, suppose I want to fetch an account who has more than 10 years. So what it will do, it will directly interact with your system program which is compiler. So it will give the command to the compiler. Compiler give the command to your software. So it will fetch the data from there. So it is very fast timing. So we are not able to identify what exactly the time it has been taking. So this is bank system. There is nothing but your application program. So evolution of OS. Evolution we can see over here. The evolution of operating system went through 7 major phases. 6 of them significantly changed the way in which user accessed computer through the open shop, batch processing, multi-programming, time sharing, personal computing, distributed systems. These are the 6. In the 7th phase, the foundation of concurrent programming were developed demonstrated in model operating system. Model operating system we are going to do check over here. So evolution of the open shop. Technically innovation, what is that? The idea of OS initially had come. Then IBM 701 open shop in 1954. This is the operating system name, IBM 701 open shop. It's an open shop. Then second is batch processing, which is the technical innovation, tape batching, first in first order in scheduling. This is the technical. Then BKS system is 1961 it come. It's a batch processing software operating system. Then multiprogramming, processor multiplexing in indivisible operations, demand paging, input output spooling, priority scheduling, remote job entry. It's come in 1961, which is example. It's Atlas Supervisor and Excel system 1966. So multiprogramming, batch processing I have told you about is everything going in the batch form. So multiprogramming, you can do a multiple program at the same time. Multi-program at the same time. It's nothing but a multiprogramming. So this kind of software has been introduced in 1961 and 1966, and this is the technical innovations for that. Remote job entry, priority scheduling. We are doing this kind of job with the help of multiprogramming software. Then time sharing. Time sharing has come, the simultaneous user interaction, one line simultaneous. User can interact with the same, so machine is one. Simultaneously multiple user can interact with that particular system. So multiple files access, Unix is 1974 SM, which is nothing but time sharing. Then concurrent programming, hierarchical system, extensible kernels, parallel programming, concept secure parallel languages. Just like RC 4000 system in 1969, 13 Venus systems, 72, it's come 72, and then BOS 2 system 75, which is called concurrent programming. It's a hierarchical system. Then personal computing, this is where GUI has been used, which we are using nowadays, graphical user interface. Operating system 672, then pilot system is 1980. Then we have a distributed system, which is the remote server, which is distributed everywhere, just like our LAN man, which we are using nowadays. It's the WS file server 1979, then Unix related RPC 82, and Amoeba system, which is 19, which has come. Then batch processing. See, batch processing. This is also a kind of operating system. A batch processing, same type of job, batch, a set of job with similar needs together and execute at a time. I told you that it execute in a batch form, and similar kind of job it is doing. Same kind of job, a set of job, and with similar jobs, with similar needs. Okay, it is going in the batch form and executing together at once. The OS was simple. Its major task was to transfer control from one job to the next. It is very simple OS, and its main task to transfer control from one job to the next. So it is moving from one job to the next job in the form of batch, and it is the batch has only the same job kind of thing. It is a set of job which has a similar requirement. Job was submitted to the computer operation in the form of punch card. At some later time, an output appeared. The OS was always resident in memory. A reference fixed next slide. Common input devices were card reader and tape drives, which is a batch processing. Initially, card reader and tape drives. Common input devices were line printer, tape drives, and card punches. User did not interact directly with the computer system, but he prepared a job. Actually, his user is basically required to prepare a job. He is preparing a job comprising of the program and data and some control information. This is OS and the user program area. So it is just like your card reader and all, it is come under the batch processing. Next, it is multiprogramming now. Multiprogramming is a technique to execute a number of programs simultaneously in a single processor. I have told you which is, we can execute a number of programs in a single time, with a simultaneous number of programs. We are processing number of programs simultaneously in a single processor. In a multiprogramming, number of processes reside in a main memory at a time. At a time, we have a number of processes reside in a main memory. The OS picks and begins to execute need of the job in the main memory. The OS picks what OS will do. OS picks and begins the execute. What is the response? OS picks and begin the execute of the job in the main memory. What the job is required, it will go into the main memory. If an input-output wait happen in the process, then CPU switches from the job to another job. If they find that there is a queue and we have to wait, so whatever the CPU will do, it will halt that job and it will move to the another job. Hence CPU is not idle anytime because it's working. See, job can be wait, but CPU cannot wait. So whatever the job has been halt at some one place, so CPU will not halt. CPU will stop that job. My mind is, it will not take that job. If it stop or halt, it will take another job and it will execute. So OS multiprogramming, it's like job work. See, you can see job 1, job 2, job 3, job 4, job 5. Figure depicts that the layout of a multiprogramming system. The main memory consists of 5 jobs at a time and CPU execute one by one. So CPU executing one by one. Number 1, job 1, then job 2, then job 3, job 4, job 5. If any time job 3 is not able to move, so it will halt on that job and CPU what will do? It will move job 4 and job 5. So advantage, what exactly the advantage of multiprogramming? Efficient memory utilization. So it is utilize the memory properly. Throughput increase, whatever the throughput is will increase. CPU is never idle, so perform immense because your machine is not idle. If machine is idle, your performance will down because your machine is continuously working. So your performance has already increased and it will increase day to day. Then time sharing system. Time sharing or multitasking is a logical extension of a multiprogramming. It's an logical extension of a multiprogramming. Multiple jobs are executed by switching the CPU between them. Multiple jobs are executing, this thing named multitasking. In this time, CPU time is shared by different processes, so it is called time sharing system. See what CPU, I have given an example. See, there is a 5 job, but in multiprogramming it will going one by one. But in the time sharing, these jobs are shared by the CPU. So they have shared that job 1 will take 1 minute, job 2 will take 1 minute, job 3 will take 1 minute, job 4 will take 1 minute, job 5 will take 1. So all the time of the CPU has been shared in all these jobs. So that's why it is time sharing system. In this time, CPU needs to share by different processes, so it is called time sharing system. Time slice is defined by the OS for sharing CPU time between the processes. So time slice is defined by the OS for share. So CPU time has been shared between all the processes. So when the job 1 will go, because for the job 1 it's a limited time. So every time it has to be processed. When the CPU has processed for job 1, then job 2. So it is time sharing. Each and every job has to be have some limited time. On that time, it has to work on that. CPU has to work on that job, like your Unix, Multics, etc. These are the operating system example of time sharing. Then operating system functions. The main function of the operating system has been written below. Just like program creation, it creates the program also. For creating a program, operating system is required. So it's the main purpose of the operating system, of the function of the operating system, I can say that program creation is also. Then program execution, which I have told you. The input-output operation in the sense writing something on the to the keyboard and output something which is coming from your output devices. all the things. Then error detection. Error detection is also a kind of work which is done by the operating system. Then resource allocation, I have told you about. Accounting and protection. Protection, I have told you, accounting of each and every job. It is also very important, which is nothing but a operating system function. Then type of OS, just like single user and multiple user, it can be classified. It's a single user or multiple user. What is a single user and what is a multiple user? The single user system provide a platform for one user at a time. So one user at a time can do any task. They are properly associated with the desktop operating system, which run on a standalone system where no user accounts are required. So at a time, a single person can work in this job. Single is the name itself says single user system. So at a time, single user can work on that job. Just like example of DOS. DOS is nothing but disk operating system, DOS. So DOS, in a DOS operating system, at a time only single user can work at a time. Then we have a multiple user system. Provide regulated access for a number of users by maintaining a database of known users. Providing regulated access of number. See, in the multiple user, its name says multiple users. So multiple user can access the system at a time. So provide regulated access for a number of users by maintaining a database to known users. Then refer to a computer system that supports two or more simultaneous users. So more than two or two from more than two can access that particular system. Another term of multi-user is multi-sharing. That is same multi-sharing or multi-user. All multi examples just like all mainframe and multi are the multi-user system. All the mainframe, whatever the mainframe is there, you can say that that is a multi-user system, multi-user or multitasking. You understand that? Multi-user system, all mainframe. Example Unix and Linux and all. Unix. Then batch processing system, a simple batch system. I have given an example which is come in the 60. You can see there, this is the batch processing. Initially it is happening. So reduce setup time by batching jobs with similar requirements. Add a card reader that time they are using. Hire an operator. User is not the operator basically. Automatic job sequencing over there. Form a rudimentary operating system, metri operating system. Resident monitor was there. Hold initial control transfer to job and then back to monitor. When their job has been scheduled, then it will come to monitor to check. Problem needs to distinguish job from job and data from program. This is the problem they are facing those days. Then supervisor operator control board, just like IBM 7094, you can see over there. It is secure monitor that controls job processing. Special cards indicate that what to do, what not to do, and user program prevented from performing input output. Separate user from the computer. There is no, so user is separate from the computer. So user submit card deck, card put on tape processed by operator, output which is written on the tape, and tape printed on printer. Problems, long turnaround time. It is taking too much of time. It is long turnaround time, up to 2 days to get an output. So it is too long. Nowadays, if you want any output, you are just writing 2 and it will show you the output. So that time it will taking too much time. Low CPU utilization. Input, output, and CPU would not overlap. Slow mechanical devices are very slow that time. Batch system. What is the issue in the batch system they are facing? Solution to speed up input output. Offline processing. Load jobs into memory from tapes, card reading and line printing are done offline. These are all done offline. Pooling. User disk, which is random access devices, are large storage for reading as many input files as possible and storing output file until output devices are ready to accept them. Allow overlap. Input output of one job with a computer, one computer to another computer. This is doing like that. And introduce notion. introduce notion of a job pool that allow operating system to choose next job to run so as to increase CPU. You see, they want to utilize CPU more and more, but because there are some reasons they are not able to do. So they are asking introduce notion of a job pool that allow OS operating system to choose next job to run so as to increase CPU utilization. They have told you how to utilize CPU more and more. Then speeding up operating system. How to speed up my operating system? This is shown over here. This is direct memory access, which is DMA. There is a CPU, there is an output devices, this is memory. So we can see over there. So in a CPU, which is central processing unit, which is machine, it is directly interact with the memory. You can see over here. Interaction of the memory with the CPU is direct indirect. So it is not one way, it is two-way processing. And the same time, input output devices also same way, I mean two-way processing, and it is connected with the IO command. For see anything, if you want to put output, so there is IO command. With the help of that, you are giving something out, something for output. So we can check over here in the channel. In place of IO devices, there is a channel has been come. So whenever you are going to give any command, so it will directly go to the channel, and from the channel it will show you the output devices. So it is showing like that. Speeding up the output. Personal computer system. What is a personal computer system? Or see, in the hardware is cheap, but nowadays human has become expensive. So single user portable IO devices like input output devices or like keyboard, mic, display screen, small printer, laptop and palm top, smart cards, wireless devices. It's a single user system, may not need advanced CPU utilization to protection features. Advantages: user convenience, responsiveness, and ubiquitous. So you can see that this if you're using the personal computer system, so what is the benefit of that? It's a single user system, so you have not much I can say protection required. The single user, single handed, so not protection. It is more utilization of the CPU, each and everything. But hardware is very cheap. Same time the human being has become expensive. Then parallel system is also operating system kind of thing. Parallel processor system with more than one CPU in close communication. So in the parallel computing system, there is not a single CPU. So there is a more than one CPU. If I can show you the example of parallel system, so it will be good to you. At least you can see. This is parallel computing. Images I can show you. You can see over here, there is a lot of CPU processor. These are control processing units. So parallel CPU is like that, parallel processing. In the parallel processing, you can see over here. This is all the parallel processing. So there is not a single CPU. So there is a multiple CPU, more than one CPU. You can see over there, more than one CPU performing each and every task. So one program, when the one program starts, so it is connected with this particular CPU. Second program is connected with this CPU, third this, and fourth with this. So in the this is provided the problem, then this is the instructions has given by that particular for that particular problem, it will go into the processor. So it is going one by one. So problem 1 going to this processor, then to this, 3 to this, 4 to this. So this is if there is a different processor for different tasks, obviously the speed will increase. The speed will increase if your CPU performance will increase so you will get good result, or you will get faster results. I can say that you will get the faster results. So multiprocessor system with more than one CPU in close communication, improve throughput, economical, and increase reliability. What I have told you about. Kinds: vector and pipeline, symmetric and asymmetric multiprocessing, distributed memory versus shared memory, it has been used. Programming models: tightly coupled versus loosely coupled, Manage based versus shared variable, these are asking about. See, parallel computing system, we can see over. This is all the parallel computing system. You can see what this number of processor has been used. This is all parallel computing system. Distributed system, this is also a kind of operating system. So hardware is very cheap and human become very expensive in the distributed system. Distribute computation among many processors. What it will do, distribute computation with, I can see this, no. So we have to go distributed computing system. Still I can show you over here. Distributed computing. You can see over there. Work has been distributed in different users. Node is single. Single node has been distributed in different users. You can see that. This is kind of distributed. So distributed computing among many processors, loosely coupled. No shared memory, various communication lines. There is a lot of lines which I have shown you. Client server architecture, this is client, this is server architecture. Advantages, resource will be shared. Speed will be up. Availability, communication. Just like example, email. Email is nothing but a kind of distributed system. Application system like digital library, digital multimedia, an example. This digital library, digital multimedia and all. Next. Then real-time system. What exactly the real-time system you can see there. Correct system functions depends on the timeliness. It's a correct function depends on the timeliness. Feedback / control loops. Sensor and actuators. Hard real-time system failure if response time is too long. Secondary storage is limited. Soft real-time system just like less accurate if response time is too long. Useful in applications such as multimedia, virtual reality. It is a correct system function. Then operating system functions. Besides managing hardware and software resources on the system, operating system must manage resources and memory, which I have asked you about. There are two board tasks to be accomplished. OS, memory storage and management. See, OS is also doing memory storage and management, what I have told you about. So each process must have enough memory in which to execute. See, when you are doing any process, whatever the process you are doing, you require some memory. Either you are writing some in the notepad, so you require a memory. If you are running a game, so you require a memory to run that game. First to store that game, then run to the game. So each and every task required memory. So the system, operating system is assured that whatever the task you are running or you are doing, either it has secure memory or not. It will not have secure memory, so it will try to give you one I can say pop-up message that there is no enough memory to install this software, and it can neither run into the memory space to another process nor be run by another process. So it will not run any memory. If the memory space is not there, so it will not run any I can say that any task, any performance. So memory management like from CPU to cache to RAM, then there is a virtual memory, then disk storage. This is your disk storage. So this is the way they are doing the memory management. Then services provided by the operating system. Program development, editors and debuggers. There is obviously every program has to be development. In the development, they require the operating system to develop that program. Program execution. So in execution, there is a requirement of the operating system. The access to I/O devices, control access to files and system accesses. To access any system, you require operating system. If there is no operating system, you can't access the system. So you can see over here, obviously there is see here, this is the Windows. Windows is nothing but your operating system. You can see over here, there is a Windows in your computer also. program files. Inside the program files you have a, I don't know, they have set up on, see, Windows Mail, Windows Media Player, Windows ND. These are all the coming from the Windows. So these are operating system supporting files. It will come automatically over here. So Windows, they have installed Windows over here, so that's why it is showing over here. See, services provided by the operating system. So I have told you the program development. So every program which is developed, anything which is developing, it's done by the operating system only. So editors and debuggers, if you want to debug some program, so the operating system also help in the debugging or find out the error. That is also done by the operating system. Then program execution has been done by the operating system. Access to IO in IO or IO devices, IO input or access. Well, I want to access some IO devices. My mind to say, if you are writing anything, see, if you are going to give an example, if you are writing anything, just like ISBM is a institute for MBA degree. I have written like this. This is also done by with the help of operating system. You can see anything I'm going to write, this is also done by with the help of operating system. So any program is done with the help of operating system. You can understand this thing. You have to understand these things. Then access of input and output devices also, like your printer, your machine, your anything which is output device. Then control access to files. Any file you want to access, any file, just like there is a lot of files. Any file I want to access from here, so there is an operating system which is support to access that file. Then system access. I want to access any system. I want to access this system also. I required. I can say that I required an operating system help. With the help of that, I can only access the system. I have told you initially, if the operating system is not there, I cannot access any system, any XYZ system, not even this system, any XYZ system. So operating system should be there to access any system. Then service provided with operating can continue. Error detection and response. Have you seen that whenever any malware or virus has been attacked to your system, so there is one pop-up come from the right hand side. It will pop up over here and will show that malware has been detected, and it will show the exactly I can say that exactly path of that particular system. So if I want to show you, I don't know whether I can. Malware detection pop-up in system. I don't know whether I can show there or not images, if the found or not. The images is there, I can show you. You can see there is a one pop-up has been shown over here. See, it is showing that there is a malware has been attacked. If malware authors even learn how to. See, these are the pop-up. You can see that this kind of pop-up has been detected over here in the right hand side of your computer, just like here. It will show you this pop-up has been come over there, and it will ask that your malware has been detected. So this is nothing but it's come through the help of your operating system. error detection and responses. Then internal external hardware errors. If there is some error has become, I meant to say your RAM has been crashed, or your memory has been crashed, anything, your hard disk has been, your multiprocessor, I mean the motherboard has been crashed, it will show you. So internal external hardware, just like memory, the device failure, your motherboard has been failure, these things you will get to know. Then software errors, just like arithmetic overflow, access forbidden memory locations, you have written everything in your memory location, so it will also show you on that. So it's a software error, then a hardware error, both errors you will get to know with the help of the operating system only. Then operating system cannot grant request of application. See, then memory management. See, memory management is also done by with the help of operating system only. Then introduction, allocation method, one process at a time. Then multi-process at a time. Then contiguous allocation, multiple processes, virtual memory. These all concepts have been used with the help of operating system only. Just like if I'm going to ask you about the memory management, what I have told you initially, the memory management. What exactly the time is required, memory is required for each and every task, it has been captured or by your OS only. So OS has been recognized that I require this much of memory to install this particular software, so this memory has to be there in your computer system, otherwise it will not allow to download that particular software and install that. So the same way it is required. So introduction. So memory management introduction. Primary memory must be shared between the operating system and user processes. So one primary memory has been, it's a share between the operating system and user process. Whatever the processing has been in the user, it has been the managed. Operating system must protect itself from the user and one user from another. Operating system must protect itself. So operating system protected itself from the user. So there is we have seen that there is a layer between the operating system and the user. So that's why it is layered. So it is not directly interact with the user and one from user to another. OS must also manage the sharing of physical memory so that processes are able to execute and reasonable efficiency. So each and every OS is responsible for sharing of a physical memory. Whatever the physical memory is available, it has been shared, also managed by the OS only, so that the processor, whatever the processing is going on, it's easy to execute. Otherwise, it's too difficult. If it is not going to share the physical memory, so it is difficult to execute for that particular task with reasonable efficiency. Then allocation method, the single process. Earlier system used a simple approach. OS had a protected set of memory location. The remainder of memory belonged to one process at a time. So OS will capture some of the memory. OS had a protected set of memory locations. The remainder of memory belonged to one process. It's belonged to one process at a time. Process owned all computer resources from process owned all computer resources from the time it begins until it completed. Process owned all computer resources from the time it begins until completed. So it will, till the time it will not complete, it will continuously run. It will resource allocation, the resource allocate the resources. Then application method, multiprocessing, contiguous allocation. Several processes reside in a memory at one time. Just multiprogramming, what I have asked you about. The entire process image of each process was stored in contiguous set of location. So it is contiguous set of location, which is it will put over there. Then drawback, limited number of processes at a time. Fragmentation of memory. See, limited number of processes at a time. So you cannot process a certain number of tasks at a time. So there is a limited number of processing. And fragmentation of memory. So there is a fragmentation in the sense we have to provide the memory to each and every task to properly, so that they can utilize that memory for that particular task. So these all we have done today. We have completed the operating system. Today we have completed the operating system. So now you have understand the operating system.